Okay, so sometimes they don't give us any method or solution about how we find the area under the curve. They just say estimate it. And they give us a grid or the graph is already given to us. So these three problems, 9, 10, and 11, are from the worksheet that you did last Thursday and finished over the weekend, where you found the areas. That's where you can find this worksheet where these three problems are, so I want to do those with you. So we want to estimate the area under the curve of negative x squared plus 7 from 0 to 1. And so I'm just going to make this the x and the y-axis. And I'm just going to estimate it best I can. If I plug in a 0, I get 7. Just there. If I plug in 1, you get 6. And it's a curve, it's a parabola, so it's kind of looking like that. And so the area it's asking me to estimate is this area here. It wants to know what that area is. So what we're going to do is we're going to count boxes. And I know it seems kind of silly, and this estimation's kind of silly, but that's usually the process that we use. So there's 1 box, 2, let's go back just a second. I shouldn't have done that one. There's 1, 2, 3, 4, 5, 6. 6 full boxes, and part of another box. I would estimate that it was 6.5 or 6.75. Your estimate just needs to be close. If you told me 7 or more than 7, I would know the answer was wrong. If you told me less than 6, I know the answer was wrong. So somewhere between 6 and 7 would be what I would be looking for on a problem like that. Alright, let's do the next one. It says from negative 2 to 5, we want to estimate the area under the curve. So here's my x and y-axis, and since I'm going from negative 2, that's the reason I put the x-axis, the y-axis where it was. So negative 2, negative 1, 0, 1, 2, 3, 4, and 5. To draw this, I'm going to find the y values at each of those places and just estimate it as I draw it. So negative 2 was 7.2. So just a little bit above 7. Negative 1 was 7.8, so even more higher, I guess. 0 is 8. 1 is 7.8. 2 is 7.2. I'll just put this in y equals and getting those values there. 3 is 6.2. 4 is 4.8. And 5 is 3. And then just kind of curve it. So if we want to find the area, we're finding the area to the x-axis. We're going to count full boxes first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. And then the rest of the boxes, I'm going to kind of just put them together to make boxes. So maybe that would be one box, so that's 42. That'd be another box, 43. Maybe those two together would be 44. That's pretty good of a box, 45, 46. So I got around 46 boxes. That would be my estimate of the area. Probably anywhere from 45 to 47 would be okay. Bigger than 48 or less than 45 probably would not be okay. So we're just making an estimate and doing the best that we can. So now we're going to do number 11. Going from negative 2 to 2. So here's negative 2, here's 2. Again, I'm just going to plug that in the calculator. Negative 2 is 4.75. Negative 1 is 4.5. 0 is 4. 1 is 3. 2 is 1. And so there's our curve. So let's find the area. I know this is fun counting these boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'd probably put that together and make 13. Probably that together and make 14. I got around 14 boxes. Probably anywhere from 13 to 15 would be okay. Try to get, oh, you know what? I missed this part right here. So I'm going to probably make that 14.5. So it's just kind of, just be careful, you know, do the best that you can and count these wonderful boxes. The only time that you're going to estimate the area this way is if they give you a grid and they say estimate the area this way. Alright, here's another example. This one's already drawn for us. And the question that they might be asking, I'm going to go ahead and label the x and the y-axis here. There's the x-axis, there's the y-axis. The question that they might be asking you is to find the area underneath the curve between 1/3 and 1. Notice these are going up by a sixth. That's a sixth. This would be 2/6 or a third. This would be 3/6 or a half. 4/6, 5/6, and this over here is supposed to be the 1. It's kind of off a little bit, but that's what's going on. So maybe they want to know the area from underneath the curve from 1/3 to 1. And again, we're just going to estimate it and count some boxes. So we've got 1, 2, 3, 4 full boxes. I would probably put those two together to make 5. Probably put those two together to make 6. These two together would make 7.5 maybe. That's almost a full box. So maybe 8.5 or 8.3 or something like that. I'm just going to say 8.5, and that would be close. Now, 8.5 is not going to be our estimate, though, and the reason is because we have to figure out how big those boxes are. On the last 3 problems, everything was going up by 1, so it was going over 1 and up 1. Well, here, we're going up by a 6, and we're going up by 10. So we have to find the area, you got to find the area of the box and multiply by how many boxes there are. So it would be 8.5 times a sixth times 10. And you get 14.166 or 7. Now, when you write your answer here, I'm going to want to see how many boxes you get and what you multiply by, because that's part of your answer. If you just put 14, I'm not going to know what you multiplied to know if you did it correctly. So you're going to have to at least write that part. There's another thing that I want to show you, and it's something called an integral sign. So I'm going to erase all of this. An integral sign represents area, as long as the curve is above the x-axis. If I ask you to find the integral from 1/3 to 1, we're going to call this f of x, dx is just a qualifier. There's nothing you do with dx. The dx is just there to say that x is the variable that we're working with, so there's nothing to do with that. The answer here would be 4.166. That was what we got as our estimate, so that's what that means. The integral sign means find the area or estimate the area under the curve. The only really tricky part about the integral is on this problem. If I said find the integral from 0 to 1/3, well, we're going to figure out what the area would be and we're going to estimate it. And instead of under the curve, you do above the curve. So you always do it to the x-axis. And so we have these boxes here. Neither one are a full box. If it's a little bit more, well, if I take part of that, maybe I'd get 1.5. So it's more than one box. So I would maybe say 1.5. But then I multiply by a sixth and by 10. So 1.5 times 1/6 times 10, and you get 2.5. Here's the tricky part. If the part that you're looking at is below the x-axis, the integral comes out to be negative. And I'm going to show you in the next few weeks like the process to figure that out. But the only difference between integral and area is that area is always positive, and it's always from the curve to the x-axis, whether it's above or below. But the integral is always negative if the part that you're looking at is below the x-axis. If I would have said, find the integral from 0 to 1, then what I would have done is I would take my estimate above the curve, that was a 1, I'm sorry, and I would subtract what I got below the curve. So my estimate would be 11.666. All right, so here's another example of that kind of thing. If I say find the integral from 0 to 2, now in these problems I'm not going to count boxes, I'm just going to find it exactly because these are triangles. 0 to 2 would be the area of that, that's just a triangle, so it would be 1/2 times the base times the height, and I get 3. The integral of 2 to 4 is going to be this area, except the answer is going to be negative because it's below the x-axis. So it would be 1/2 times 2, because the distance from there to there is 2, times 1. So I get -1. And then the integral from 0 to 4 would be the positive part minus the negative part, and I get 2. If the problem would have said find the area between the curve and the x-axis, then my answer would be 3 plus 1, which is 4. And so I don't consider whether it's below the x-axis or not. Integral considers it, area does not. So I want to show you on the calculator there's a way to find it exactly, and I've been telling you that you can. So let's just go ahead and put this in the calculator, 4 minus x squared. And what I want to look for is the integral of 4 minus x squared from 0 to 2. I want to figure out what the area underneath that curve is from 0 to 2. So I'll go to y equals. There's a couple ways to do it. We're going to go to the graph. And I'm looking for that area right there, 0 to 2. So on the graph, here's what you do. You go to second, calculate. Remember 6, that's the derivative. 7 is the integral. It says lower limit, so start with 0, press enter. Upper limit, we want to go to 2, so press 2, press enter. It'll shade it for you, and it tells me the area is 5.333. Now, I want to show you also that in the regular screen, that sometimes there's a case where instead of just looking at the graph, we just need to look at what the equation would represent. You go to math, you go to, FNINT, that means function integration. We're going to go 0 to 2. You could put y1 right there because that y1 is what you have in y1, or you could just put the equation. You have to put an x there to tell it the x is the variable. Press enter, and it will give it to us there as well. There's sometimes if you go to the graph that depending on the decimal, if it's a really big area, the decimal won't be rounded correctly, so this is the better way just to make sure you can see it. But I wanted you to see both ways just so that you have an idea about it. Alright, let's do one more. And I want to show you this one. Let's say that negative x plus 3 is the graph that we're looking at, and we want to find the area between the curve, or we want to find the area between the curve and the x-axis. from 1 to 4. If I go to second calc, number 7, and then 1, and then 4, that's not the area. That's the integral from 1 to 4. And the reason I know it's not the area is because there's a part above and below the x-axis. So what I would really need to do, let's clear this off. I really need to find the area from 1 to 3, and then find the area from 3 to 4 and change it to positive to find the actual area. So if I'm going to do it this way, I'm going to go from 1 to 3, because 3 is where it touches the x-axis, I get 2. Then I'm going to go from 3, oops, that was not right, 3 to 4, and I got negative 0.5, so the area is going to be the 2 plus 0.5, so you get 2.5 instead of 1.5 for the area, if that's what it was asking. Here's your try problems. Number 1, I just want you to use the calculator to find that area. 2, 3, and 4, I want you to find the areas exactly, and then figure out how to write that in the integral form. There's no practice on estimating. We'll practice on that some more tomorrow in class.